All right, these notes are going to review with you how to do a one-step equation and what your format needs to look like and how you go about solving them. They can also be used to help you with any other equations as we get larger ones and harder ones throughout the unit, right? But every single one of you has seen this before. It's just a matter of refreshing your minds on what to do with it. All right, the first thing we're going to do is start with defining a couple of words pertaining to equations. The first one being solve, right? And solving is the ability to find an answer to the variable that makes the equation true. All right, so when we are solving an equation, we are actually doing the process of getting an answer, right? So that's what it's called. And then as you are solving it, you are coming up with a solution, and the solution is the answer to the problem, right? So for solutions, the official definition is the value of the variable in an equation. All right, so we have to solve it in order to come up with a solution, right? The next thing that you need to be aware of is what we are using to get these solutions, and it's something known as inverse operations. And if you remember back from our properties not too long ago, inverse properties dealt with opposites, so inverse operations are dealing with opposites, and that letter O can help you remember the word opposite since they both start with the same letters, right? And these are operations that undo each other. So there are four main ones that we are going to have to make sure we understand, and that's addition will undo subtraction, subtraction will undo addition, multiplication will undo division, and division will undo multiplication. And those are the main four that will get us through all of the equations that we will have to do this year. Right? Before we go into the examples, there's some key points that I want to emphasize to you as we're going to solve equations, and this works for any equation, not just the one step. Right? So they're important to start with, and these are your main points to solve any equation. Right? The first one is that format counts. And by format, we're talking about how you show your work and what it looks like. Right? There's a certain way that equations have to be shown in terms of their work for it to legitimately come out to the answer that it is, and for you to be using the inverse operations the way you should be. So format counts big time. And along with format counting, you have to be able to show all of your work. Because if you are trying to do too many steps at one time or skipping steps, your format doesn't look the way it should and your answer is going to come out incorrectly. And then the third most important part of solving an equation is what the goal is. And the goal is always to get the variable alone. You are not finished with the problem until the variable is completely by itself with an actual answer. Right? If there is more to do, then you are not finished. Right? So the rest of our notes are going to be examples of different types of one-step equations that you may encounter over the next chapter. Okay, and a lot of these you have seen before, and some of them may be newer to you or look a little different, but they're all considered one-step equations. One step means it takes one operation to get to your answer, right? And there's a lot of different varieties out there, so that's why there's going to look like a lot of examples. As we get into the harder ones, there's not as many different varieties, so it doesn't take as many examples to get it across. All right, so the first one is y plus 3 equals -8, right? Many of you may have had your teachers in the past talk to you about drawing a line where the equal sign is. I call that the wall, right? And your goal is to get the variable by itself, and you do that by getting rid of whoever's on the same side with them together, right? So in this case, if I want to get y by itself, I have to get rid of adding 3. And the way we get rid of adding 3 is to subtract 3 on both sides. And what this does is this allows us to cancel out the number. Positive 3 minus 3 makes 0, so now it's gone. That leaves us with y equals, and then you do the math on the other side. Negative 8 minus 3 is negative 11. So there's the answer. And that's the correct format as well. Right? So you want to make sure that you're showing your work, showing the format, and coming up with the right answer. Right, so another one that looks very similar but does have a different twist on it is 5 equals n minus 4. Right? You'll notice if you draw the wall that the 5 is first and the n minus 4 is on the right-hand side. It just looks backwards. Right? But really you're not doing anything different than what you were doing before. If I want the n to be by itself, I have to get rid of minus 4. The opposite of minus 4 is plus 4. And then we cancel the 4's out. 5 plus 4 is 9, and 9 equals n. Now at this point you can stop right there because you've answered the question. Some of you don't like having the variable on the right-hand side, so if you want to reverse it and write n equals 9, then you certainly can. I don't penalize you for either one. All right, the next example is going to have some double signs in it, and that's where some students tend to get a little mixed up because they're not sure which one to do the opposite of. All right, so hopefully this will straighten you out when it comes down to that. Right, when you have double signs, the very first thing you want to do is get rid of them and rewrite the equation. You never want two signs in your equation because then you're not going to know which one to do the opposite operation of. So if I rewrite this, this is really d minus 11 equals negative 8. And now that I can see what my sign is, I know what operation to do. I want to get rid of minus 11, so I'm going to have to add 11 to both sides. Cancel out the 11s, and now I get d equals 3. Right, so once you get rid of those double signs, the problem becomes a whole lot easier. Okay. Another type of example is going to have the number in the front of the variable so that it looks like this. And for some students, this is a hard one to deal with because you're not quite sure what's going on because you don't see a sign helping you out. If I want to get the x by itself, I have to get rid of that 30 that's hanging out in the front. Well, that 30 is a positive 30, which means it's being added to the problem. So if I want to get rid of adding 30, I'm going to have to subtract 30. Remember, you have to make something zero out in order for it to go away. So 30 minus 30 is gone, and now that leaves me with x equals, and 9 minus 30 is going to be negative 21. Okay, so just be careful with that number in the front and make sure you're doing the opposite operation of what it is. Right? Along with all of these one-step adding and subtracting ones, we're going to find that you're going to have to deal with fractions and decimals. So let's start off with a decimal one, and then I'll show you what a fraction one looks like. If we have negative 8.07 equals r minus 4.48, okay, you can still see that you want to get the r by itself, so we have to undo minus 4.48, and that's where we would add 4.48 to both sides. Okay, and cancel off the 4.48s, and then you just do your regular math using your calculator. Negative 8.07 plus 4.48 is going to give you negative 3.59 equals r. And if you want to reverse it and write it with r equals first, then you can do that. Otherwise, you're finished. All right, for the next one, now we're going to throw in some fractions, right? And you have to be able to do equations with fractions in them without changing them to decimals. So you do have to have a little bit of working knowledge about fractions before you can continue this. Negative 5/8 equals x minus 1/4. Right? If I want to get x by itself, I've got to get rid of minus 1/4. And the way I'm going to do that is add 1/4 to both sides. Now, when you're adding and subtracting fractions, remember you have to have a common denominator, right? So for 8 and 4, the common denominator is going to be an 8. So the top fraction is good. It's the bottom fraction that I need to turn into something over 8 before I can add or subtract it. So in order to get from 4 to 8, I'm going to multiply the bottom by 2, which means I have to multiply the top by 2. 1 times 2 gives me 2. So now I'm going to take and not use the 1/4, but I'm going to take negative 5/8 plus 2/8. And if you add the top numbers together, negative 5 plus 2 is negative 3, and keep the denominator of 8. Negative 3 over 8 does not reduce, so you know you're done on that side, and it equals the x on the other side. Do not turn that answer into a decimal. If you have fractions in your problem, your final answer must remain a fraction. And likewise, if you have decimals in your answer, you want to keep the decimals in your answer as well. All right, for the next few examples, now we're going to focus on the multiplying and dividing side of things. Right? So let's take a look at a few of those. If I have y over negative 4 equals negative 8, right? Y over negative 4 is the same as saying y divided by negative 4. So to undo division, we're going to multiply. When we multiply, you always want to put it diagonal from the bottom so that it'll cross off. You don't ever want to put it side by side. So negative 4 times the negative 4 on the bottom, crosses them off, and that gives you y equals, and then negative 8 times negative 4 is positive 32. So you'll notice it doesn't take as much paper space as the other ones did. It's just because of the format that goes along with them. All right, so let's take a look at another one. If I have negative 12 equals negative 6k, remember negative 6 touching that k means multiplication, so negative 6 times k. If we want to undo that, we're going to have to use division. You don't use the elementary division sign, you use the division bar on both sides. And whatever number is attached to that letter, that's the number you want to get rid of. Don't change the sign, take the exact thing. So if negative 6 is multiplied to that k, we have to divide by negative 6 to make it cross off. Otherwise, it doesn't cross off. All right, negative 12 divided by negative 6 is going to give you positive 2, and that's the value for k. All right, the next one is going to show you that we can do the same thing with decimals. So if we have negative 5.04 equals 1.26d, again, 1.26 is being multiplied to the d, so in order to remove it, we have to divide both sides by the 1.26. Otherwise, it won't go away. And then when you type it in the calculator, negative 5.04 divided by 1.26, it comes out nice and clean, negative 4 equals d. Sometimes your decimals work themselves out and they go away. Other times they remain. All right, for the next three and last three examples, right, we're going to be dealing with fractions, and there's a special way to handle these when it's involving multiplying and dividing. All right, so I want you to put this side note first before I show you what those examples look like. To get rid of a fraction, in front of a variable, you are going to multiply by the reciprocal. And if you recall back in the inverse of multiplication property, how we have to multiply by the reciprocals to make fractions go away, that's exactly what this is having you do. All right, so I'm going to show you a few of them, and then we'll practice with them some more in class to make sure you get really good at them. All right, so if I have 1/5 x equals 6, right, the fraction in front of my variable is 1/5, and that's the one I want to get rid of. So that's the one I'm going to multiply the reciprocal by. The reciprocal of 1/5 is 5/1, so I'm going to do that on both sides. And then that means that my 5's cross off and my 1's cross off. If your fraction doesn't do that, then you haven't done it correctly. Right? Then you have your x. And then on the other side, if I put 6/1, okay, you can just multiply straight across. 6 times 5 is 30, and 30/1 is really the same thing as the number 30, so you don't even need the 1 on the bottom. So the answer is just 30. All right? If we look at another one, negative 2/3 equals 3/4 p. Okay. The one thing that students often have trouble figuring out is which fraction do you do the reciprocal for? It's always the one that's connected to the letter. So in this case, we're going to do the reciprocal of 3/4. And the reciprocal of 3/4 is 4/3. So we're going to do that on both sides. Okay. The 4's cross off, the 3's cross off. That leaves you p on the right-hand side. Right. And then if you look at your fraction on the left, right, there's no simplifying you can do. So with multiplication, you can literally multiply straight across. 4 times negative 2 is negative 8. 3 times 3 is 9. Negative 8/9 does not reduce, so your final answer is negative 8/9. Again, do not make them decimals. They must stay fractions. Right, and then one more example, and the last example we'll do together here, right, is negative 3/8 y equals negative 6. Okay, and again, the negative 3/8 is what's touching the variable, so that's the one we're going to do the reciprocal for. So we're going to flip it, multiply by 8/-3 on both sides. Cross off your 8's, cross off your negative 3's, so you have y equals, right? And then over here, you want to put a 1 underneath the 6, right? And the first thing you want to take a look at are the signs. If you take a look at, we have a negative times a negative, so our answer is going to be positive, so we don't even really need to worry about the signs, okay? But we do want to take a look at the numbers 3 and 6. Because they're diagonal from each other, we can reduce them. 3 goes into both of them. So if we take 6 and divide by 3, that leaves us a 2. If we take 3 divide by 3, that leaves us a 1, right? And then we can multiply straight across and get our answer very fast. 2 times 8 is going to be 16. Okay, so we're going to keep practicing with the reciprocals and making sure that you're good with them. But this is all the different varieties of a one-step equation that you may run into.